Hi ladies and gents, so this is actually my first grade 10 physics video that I'm going to be uploading to my channel. In today's video we will be covering grade 10 physics electrostatics. We'll be going through past papers dealing with calculation questions as well as a bit of theory questions. So for all the new viewers, I hope you guys enjoy the video today. And if you have not yet subscribed, please do so, and don't forget to hit the notification button to receive future updates on when new videos will be released. And if you'd like to get in touch with me, you can actually find my contact information in the description below. So with all of that out of the way, let's get started. Please note, I do not claim to own the rights to the question papers displayed. They are the property of the Department of Basic Education and are only displayed to solve the questions. Our first question of today is from a November 2015 exam paper. So, question 10 reads as follows. A learner in a physical sciences class rubs his hair with a plastic rod. The rod becomes negatively charged. The learner now opens a tap so that a thin stream of water runs from it. When the rod is brought close to the water without touching it, it is observed that the water bends towards the rod as shown in the diagram below. So, what basically happens is that because water has polar molecules, so the hydrogen molecules are more positively charged, whereas the oxygen molecules or the oxygen atoms are more negatively charged. So that's why we refer to water as having a polar charge, as having polar molecules. So the end that's more positively charged in the water, which is the hydrogen end, now becomes attracted to the negatively charged rod. We can see that the rod is negatively charged by the negative signs on the rod, as well as from the question which stated that the rod is negatively charged. So, due to unlike charges attracting one another, the positive end of the water now attracts the negatively charged rod. So our first question, question 10.1, write down the principle of conservation of charge in words. So the principle of conservation of charge states that the net charge of an isolated system remains constant or is conserved. So the system has to be isolated in order for this principle to apply. Our next question, question 10.2, give a reason why the stream of water bends towards the rod. So just like I explained before, because the molecules in the water, because the water has polar molecules, where the hydrogen is more positively charged and the oxygen is more negatively charged. The positively charged hydrogen now attracts the negatively charged rod. So due to unlike charges attracting one another, the water will bend towards the rod. So let's just write this out in words. So our question 10.2. So due to unlike charges, the positively charged hydrogen atoms in the water attract the negatively charged particles in the rod. So that's basically our explanation, and that's 2 marks. So our next question, question 10.3. So question 10.3 is a calculation question now. So we've got, during the rubbing process, 10 to the power 4 electrons are transferred to the rod. calculate the net charge now carried by the rod. So whenever we deal with charges being carried or number of electrons, we use this formula. Q, which represents charge, is equal to the number of electrons times the electron charge. And QE is the electron charge, and QE is also a constant. So QE has a value of negative 1,6 times 10 to the power negative 19. So if you struggle to know where I got this from, you can look at the last page of your exam paper and you'll find all of your constants and your charges. So here's our QE value. Here they just wrote E, but you can write E or QE, it doesn't really matter. Okay. So let's continue with our question. Next, we were given that the number of electrons is equal to 10 to the power 14 electrons. And our Q value is our charge that is unknown. So Q is what we are actually trying to calculate. So let's substitute what we know. So we know that N is 10 to the power 14, and we know that QE is 1,6 times 10 to the power negative 19. So when we put this on our calculator, we then have our charge as Q is equal to negative 1,6 times 10 to the power negative 5 coulombs. And that is our answer for 10.3. So our rod now carries a net charge of negative 1.6 times 10 to the power negative 5 coulombs. Our next question for today is from the November 2016 exam. So our question 10 reads as follows. Two small identical spheres A and B are suspended on long silk threads, as shown in the sketch below. The spheres carry charges of positive 3 times 10 to the power negative 6 coulombs and negative 2 times 10 to the power negative 6 coulombs respectively. So we've got sphere A that's positively charged and sphere B that's negatively charged. Our first question, question 10.1, which sphere has an excess of electrons? So if a sphere has an excess of electrons, that means it's more negatively charged. Whereas if a sphere is electron deficient, it means it has less electrons, it's short of electrons. That sphere is more positively charged. So our question wants to know which sphere has an excess of electrons. So we look at our more negatively charged sphere, and that is sphere B. Question 10.2. The two spheres are allowed to touch. Will the electrons be transferred from A to B or from B to A? So electrons always move from a negatively charged sphere to a positively charged sphere. So from negative to positive. So electron B is going to donate electrons to, sphere B is going to donate electrons to sphere A. So our electrons will be transferred from B to A. Question 10.3. The spheres are now separated. Calculate the new charge on sphere B. So the spheres, when were released, they came into contact. Electrons were transferred from A to B. So now each sphere will then have a new charge. So after the electrons were transferred, the spheres separated. And now each sphere has a new charge. So when we're calculating when spheres come into contact and when they separate, when we calculate the new charge, we use the equation Q is equal to Q1 plus Q2 all over 2. And this is our question 10.3. So we know that charge 1 or sphere 1 is our A sphere. You can even take sphere 1 as your B sphere, it doesn't matter, as long as you add up both of them. So we're going to add up sphere A and sphere B, and we've got positive 3 times 10 to the power negative 6 plus negative 2 times 10 to the power negative 6, and this is all over 2. So if we had 3 spheres, we'd add up all 3 of their charges and divide it by 3. But because we only have 2 spheres, that's why we divide by 2. So now, once we put this on our calculator, we then have each individual sphere now has a charge of 5 times 10 to the power negative 7 coulombs. So before, the spheres had a charge of positive 3 times 10 to the power negative 6 coulombs and negative 2 times 10 to the power negative 6 coulombs. That was before they touched. Now they touched, electrons were transferred from B to A, and then they were separated. After they separated and after the electron transfer, each sphere now carries a charge of 5 times 10 to the power negative 7 coulombs. Our next question, calculate the number of electrons transferred during contact. So whenever we're dealing with electron transfer, what we do is we use this formula over here. Our Q is equal to NQE. So I'll repeat that one more time. Whenever the question specifies number of electrons transferred, we use our formula that has N in it, the one that has number of electrons. So what we know is that our Q is actually equal to the change in our charge, because we're calculating how many electrons were transferred. So we take our final charge minus our initial charge. So let's just rewrite this formula. So we have N, which is our number of electrons transferred, is equal to the change in Q all over our electron charge. And the change in Q is equal to Q final minus Q initial, and that's all over our electron charge. So we can either use sphere A in our calculation, or we can use sphere B. We'll get the same answer. So let's just go with sphere A. So our N is equal to our final charge. So after the electrons were transferred, what was our final charge? So our initial charge is the charge of sphere A before the electrons are transferred, and our final charge is the charge of sphere A after the electrons were transferred. So we know that after the electrons were transferred, our sphere A carried a charge of 5 times 10 to the power negative 7 coulombs minus, now our initial charge. Our initial charge is the charge of sphere A before the electrons were transferred. And that's positive 3 times 10 to the power negative 6. So we've got positive 3 times 10 to the power negative 6. And this is all over QE, which is our electron charge. And that's negative 1,6 times 10 to the power negative 19. So after we put this on our calculator, we then have the number of electrons that were transferred from sphere B to sphere A as 1,6 times 1,56 times 10 to the power 13 electrons. So there was a total of 1.56 times 10 to the power 13 electrons that were transferred from sphere B to sphere A. So let's do the same calculation, but now instead of using sphere A, let's use sphere B. So we know that our final charge is going to be 5 times 10 to the power negative 7 coulombs. Our initial charge is going to be the charge of sphere B, which is negative 2 times 10 to the power negative 6 coulombs. So our formula is N is equal to change in Q over QE, which is then equal to QF minus QI all over QE. And our final charge is 5 times 10 to the power negative 7 minus our initial charge of negative 2 times 10 to the power negative 6 all over negative 1,6 times 10 to the power negative 19. And when we put all of this on our calculator, we then once again get 1,56 times 10 to the power 13 electrons. So whether we use sphere B or sphere A, we still get the same answer. So to conclude, there is a total of 1,56 times 10 to the power negative 13 electrons that is transferred from sphere B to sphere A when they touch. Our next question is from a 2018 November exam paper. So question 10 reads as follows. Two identical insulated spheres X and Y suspended by threads from a ceiling are held at a small distance apart, as shown in the diagram below. Sphere X carries a charge of positive 4 times 10 to the power negative 18 coulombs, while sphere Y has an excess of 30 electrons. Because it has an excess of electrons, that means it's more negatively charged. 10.1. Calculate the magnitude of the charge on sphere Y. So, because we have the number of excess electrons that are on sphere Y, we can then use our formula for number of electrons, which is Q is equal to N QE, and that's question 10.1. So like I mentioned in the previous questions, whenever you're dealing with number of electrons, you always use this formula that has n in it. So let's calculate the charge on Y, which is then equal to 30 times negative 1,6 times 10 to the power negative 19. Once we put this on our calculator, we then have the charge of sphere Y as negative 4,8 times 10 to the power negative 18 coulombs. Our next question, question 10.2, the spheres are now released and they move towards each other. Give a reason why spheres X and Y move towards each other. So because X is positively charged and Y is negatively charged, unlike charges attract one another, and that is why the spheres will move towards each other instead of moving away from each other, instead of repelling one another. So to answer the question, you just say that like charges attract one another. Because X is positively charged and Y is negatively charged, the two spheres will come together. The spheres are allowed to touch each other. After touching, they move away from each other. 10.3. State the principle of conservation of charge. So, the principle of conservation of charge states that the net charge of an isolated system remains constant. Our next question, question 10.4, which is actually our last question of this video. So, calculate the charge on each sphere after they are separated. So, whenever we calculate the charges on individual spheres, or whenever we do calculations involving when spheres touch one another and are then released, we always use this formula. Q is equal to Q1 plus Q2 all over 2. And this is our question 10.4. So we know, let's make Q1 our X sphere. So we then have Q is then equal to positive 4 times 10 to the power negative 18 plus Q2, and let's make Q2 our Y sphere, and we know our Y sphere has a value of negative 4,8 times 10 to the power negative 18, and this is all over 2. So once we put this in our calculator, we then have the charge on each individual sphere to be negative 4 times 10 to the power negative 19 coulombs. So before the spheres come into contact, before the spheres are released and touched, sphere X has a charge of positive 4 times 10 to the power negative 18 coulombs, and sphere Y has a charge of negative 4.8 times 10 to the power negative 18 coulombs. So once the spheres are released, because they have unlike charges, they attract one another and touch. After the spheres touch one another, they then go back to their original positions, or they move away from one another. And once they move away from one another, electrons are transferred from sphere Y to sphere X while they are in contact, while they're touching. And once they move away from one another, both spheres are now negatively charged, and each sphere carries a charge of negative 4 times 10 to the power negative 19 coulombs each. And that's it for today's video. I hope you guys enjoyed our first grade 10 electrostatics video. If you guys would like to see more, please subscribe to the channel to be notified whenever future videos are released. Thank you guys for watching. Bye.